Welcome to our social homework project. This is our presentation on Cycle 1 for Homework Hub. I'm Nate Mitz.
I'm Robert Zambito.
And I'm Biagio De Vivo.
Our system intent was a social media platform for students to upload and view homework assignments. Our intent for Cycle 1 was to create a mock community full of test users that we can use to test our user interaction, upload an image to the site, and create a single repository with all necessary resources to run the project on a local machine.
Features. We did not focus on user-oriented features during this cycle. Most of our time was spent working on certain technical features that enable us to develop user-oriented features during the upcoming cycles.
We defined two flows for our architecture on the website. We defined a read flow, which the client makes an initial request to the web server, and the web server will then query the database for post information. The database responds with post data, and then the web server will generate an HTML file and respond to the client with a list of posts. The client can also choose to post an image to the web server. The web server will then store metadata about the post, such as the date created and course information, and will also associate it with some path to the file on the file system.
Plan for Cycle 1. Our overarching goal or plan for Cycle 1 was to cement the necessary framework for Homework Hub so that we could begin focusing on more user-oriented features within our project. Here were our primary short-term goals, namely creating bash scripts and organizing our Git repository so that the project can be loaded and worked on by any local machine. Also, furthering working on things we consider core to the functionality of Homework Hub, such as storing data and user info on a MySQL server and uploading files.
Our plan for the next cycle. The plan for the next cycle is going to be centered much more around user features as opposed to the actual framework for the functionality of Homework Hub. Some of the features we plan to be working on include a feedback mechanism for content posts on Homework Hub. This will assure a level of quality control which is generated from users of the application. Addition of tags to uploaded content for organizational purposes, making it possible for users to view content based on certain criteria, for example, computer science, mathematics, etc. And finally, a method of user creation from the site.
Now we'd like to show you some of what we have accomplished so far. In this demonstration, you can expect to see the creation of test users that we can use in our mock community, a site which is dynamically rendered, bash scripts to install the dependencies needed to run the site, and file uploading.
In this demo, we have a script that is used to create test users to fill our database, and we will be using these users to show our mock community on how users would interact with each other. In the script, we use readers, so we can create our test users, and they are stored as variables such as username, email, isadmin, and the password hash. Then our script accesses the database, uses the database's name, and then inserts our information into our data through our db.exec function. And over here we insert all of our variables into the database. Now when we run the script, we're able to write a test username, a test email, if the user's admin, and a random password hash that would be generally created usually. When we select all from user info, we'll be able to see the test user that we just created.
This over here is the Go script that is responsible for uploading and handling files to our Homework Hub project. And about it, I've encountered a number of bugs with this, and I just keep continuing to try and get it. So we're gonna go ahead and run this. Alright, and so once we run the script, it'll open up a connection with a local host. So now that we've done that, we can go ahead and use this bit of HTML over here, right? And if I just, where we're able to choose a file from somewhere in, you know, your local machine, such as this pleasing image, and supposedly upload it to the site. And that's what I expected to happen. That's coming from right over here.
This demo, I will be rendering a HTML document dynamically through the web backend. Here we're using the Go standard templating library to generate a set of templates here that are defined as .go.html files. And what this allows us to do is build a structure for how the site should be built, and then at runtime insert information. For example, we have an index page that is inserted into our shell includes template that has all of our CSS and JavaScript files included. In this Go HTML file index page, we have the content that's actually displayed on the page. So when I launch this web server, we can see the interface that we created previously is being hosted, run and built dynamically at runtime, so that we can choose to change the information based on user activity. The next demo is our init scripts for creating and installing the dependencies required to run our final project. So in this init shell script, we're installing MySQL server if it's not installed on the machine, and if it is, it recognizes that and leaves it be.
Just gotta wait for the mouse.
Oh, it still says architectural spike.
No.
Oh, that's me.
Used during the architectural spike.
These are tools we began with during the architectural spike, but none of the tools we have used are tools that we began.
Oh, okay. I see now.
I thought it was just like, because why on earth would we like use all the tools?
Right.
It's like, don't look that cheap. That's just
It's recording, right?
Yep.
Right. Tools used. A number of the tools that we used are tools that we began using during the architectural spike. These include the Go programming language, MySQL, GitHub for collaboration, Git as well, curl to test your web server endpoints, Twitter Bootstrap to design our front-end web interface, and various other internet resources for development.